Hello, welcome back. So let's see some questions on time complexity uh, uh, based on what I have explained in the previous video. I'll give you some hints also in this particular video, right? So here we go. Yes, I have an algorithm here, a pseudocode, basically a pseudocode, right? So yeah, this code is, I have to find the time complexity of this particular algorithm. So let's check what happens. So here I'll be having a single statement, so it will execute one time. That's not going to contribute much to my time complexity. So I will be ignoring those, right? I'll be ignoring those single statements throughout this discussion. So okay, let's ignore that because when you talk about big O, it is something big, right? So you can always ignore that single or double statements, okay, right? Even if you have a 100 single statements like this, even if you have 100 single statements like this, the time complexity is still of 1, right? Okay, let's say I have 100 statements like this in my program, the time complexity is still of 1, the constant time complexity. So uh, my intention is to find time complexity only. So I'm not gonna find the total frequency count. Let me find only the time complexity. So I'll be ignoring the declaration statements and all, right? Super. So here you can see the for loop. For loop starts from n by 2, it goes up to n, right? So this for loop will have a complexity of upper index, that is n, lower index, that is n by 2 plus 1, right? I told you this, upper index minus lower index plus 1, right? And it is n by 2 plus 1. N minus n by 2 is again n by 2, so n by 2 plus 1. So this for loop will execute for n by 2 plus 1, or else you can say n by 2 times. That's it. This for loop will execute for n by 2 times. And since these loops are nested, this will also execute for n by 2 times, and this will also execute for n by 2 times, and this will count. This count statement will also execute for n by 2 times, right? Again, you check for this loop, the inner loop, this one, right? This loop, okay? So again, this starts from 1, it goes up to n, but see the increment statement. Could you remember this? 2 into j. Even when you are multiplying, your problem is getting cut down by a fraction. Understand that when you are multiplying the counter variable or the iterating variable, when you are multiplying by 2, you are cutting down the problem by a fraction of 2. Okay, cutting down the iteration, right, by a fraction of 2. We clearly saw this in the previous video, right? How to identify the time complexity in such case, right? So this for loop, let me erase this. This for loop will run for log n times. You know that, right? Why? Because this is 2 into j, so it's getting multiplied, so that will run for log n. I have explained that in the previous video, right? And this is also 2 times it is getting increased, so this also will run for first of all, let me finish this off, okay? So this is log n means everything inside the loop will go for log n, right? Okay, because all are nested, right? So you have to select one loop and you have to go up to the end, select the other loop and go up to the end, select the last loop and go up to the end. That's the concept, right? So if this is log n means everything inside the loop will also go for log n, right? And now I'll go for this loop. This loop will again execute for log n times, so I'll again have log n, and everything inside the loop is again for log n times, right? So now if I look at the time complexity of this particular algorithm, it is I am having, what I'm having here is 2 times n square by 2 n square by 4 log n square. Okay, so I'm just clubbing these two. I have to add all the terms, right? So this is first term, second term, third term, and fourth term. I have to add all the terms. Before that, I'm just performing multiplication. So here I'll get n by 2 log square n, right? Here I'll get n by 2 log square n. So if I add those two, and I'll get n square by 4 log square n, right? 2 times, because there are two terms, plus n by 2 log n plus n by 2, right? But if somebody asks me the time complexity, that is the big O, I would definitely say that this is This is the time complexity. Okay, and there is no need to write like that. You can go for your own notation. That is, you can ignore the constant, so you can write like this: O n square log square n. This is the time complexity, and this is a special case, of course, right? So n square log square n. Okay, that's how it was. Okay, let me go to the next problem. Okay, so next problem is here. Again, it may look simple, but this is tricky, trust me that. Okay, so yeah, this is simple statement. So let me, okay, here is a if condition here, right? And if only if n equals to equals to 1, you just return something. Okay, returning means the end of the function, right? Returning is the end of the function, right? So the control will again go to the main function whenever you encounter the return statement, right? So in this case, if I assume this condition to be true, then my function will return nothing, and the time complexity is actually O of 1, right? Because only one statement is executed. Okay, rest of the statements are not executed. But that is not the correct way to analyze the algorithm. You have to always look for the worst case. Okay, when you are analyzing the time complexity, you have to look for the worst case and see how the algorithm performs well in that worst case. Okay, so you have to compare algorithms only in terms of worst case. Okay, this is called as best case. Okay, where the time is it is rapidly reduced. Okay, if you assume a single condition to be true, means the time is getting reduced here, right? So this is not the correct way. Okay, so instead of that, what I can do here is I have to assume this condition to be false. Okay, so that nothing will be returned. I will be executing these statements. Okay, so that is the idea here. Worst case, I have to assume that condition to be false. Okay, super. So this for loop will go n plus 1 times, of course, n minus yeah, it's n times, of course, n minus 1 plus 1, so n times, and everything will inside the for loop will go for n minus 1, n minus 1, n minus 1, right? Okay, super. But if you look at this for loop, this for loop will go only for, will execute, you may be saying this also will execute for n minus n times, so you can write n here, but that is not the case here. That is a trick, that is a break statement here, right? Which means that this for loop will go only for the first iteration, which means there is no use of having this for loop. Okay, why? Because at the time of the first iteration itself, it will print the star and it will break the loop. It will again get back to the outer loop. Okay, at the time of first iteration itself, it will encounter the break statement. Because of that reason, I'll consider that this for loop will execute only for one time, right? This for loop will execute only for one time. So the idea here is will execute only for one time. If that is the case, then I couldn't write anything n here. I just write 1 1 1. That's it. Okay. If I add these up, you'll get 4n minus 3. So the time complexity becomes On, right? I have to ignore the constant, so the time complexity becomes O of n. Understand that because of this break statement, because of that break statement, even if I have two loops, I got only O of n time complexity. Why? Because at the time of first iteration itself, the loop will break. So there is no provision for this inner loop to iterate completely up to n. Okay, to iterate completely up to n, there is no provision. We have only break statement that will break the loop. So even if I have two loops, I'll have On. This is a tricky question, guys. Don't merely write On square. Okay, so since you have got two loops nested, don't merely write On square. Okay, this some statements inside the loop may affect you, right? So let's go for the next question, right? Yeah, next question is here. I think it's pretty simple, but that's the trick here, right? So you can see this will go only for n plus n times, I could say n times. It doesn't matter when I say n or n plus 1 or n plus 2, both refer to the same big O, right? O of n, so it doesn't matter, right? Anyway, we're going to ignore all the constants while we're finding the big O, so let me take n alone, no problem, right? So don't care about that. Okay, if you have single for loop, it will execute for n times, that's it. except for the special conditions that you give here, I equals to I into 2, where it will execute for log n times, right? I hope you remember that, right? Okay, wait. Oh my god. Okay, so this for loop will go for n times. Sorry guys. This for loop will go for n times, and this for loop immediately you can you can very well claim that this will also go for actually n minus 1 times and n minus 1 time because of the outer loop. Okay, when you are considering the outer loop, don't care about the expression, you just write n minus 1 and n minus 1, that's it. Okay, you know that if the outer loop goes for n times, then everything inside the loop will be executed for n minus 1 times, right? So you write n minus 1, n minus 1, that's it. Okay, and now you consider the inner loop. Okay, if you consider the inner loop now, this is j equals to 1, j less than or equals to n, j plus equal to I, which means that j equals to j plus I. So it is not j plus 1. If I say I plus plus, it means that I equals to I plus 1. Okay, but here j plus equals to I, which means that j equals to j plus I. Okay, j is increasing at a rate of I. Okay, j is here, the important point is to note here is j is increasing at a rate of I, at a rate of I, not at the rate of 1, not at the rate of 1, right? Whereas usually loops will have this habit I equals to I plus 1, but here this is not the case. It depends on I, right? If that is the case, then what you have to do, this will not go for the whole iteration, this will execute only log n times. Okay, so everything inside the loop will also go for log n. Okay, how do you claim that? Let's say my I equals to 1 and j becomes 2. In that case, okay, in that scenario, j becomes 2. When I say I becomes 2, then j will be incremented in this manner. I equals to 1, 2, 4, 6, 8. Okay, so j will be incremented in this manner when I equals to 2. So since j depends on I could say it will not execute for the whole n times. Okay, sorry guys, it will not execute for a whole n times, it will execute only for log n times. So that's it. And if I check for the time complexity, that is I have to add all these, right? So I'll get big O of n log n, right? I just have to add, that's it. So here I'll get 2 times n minus 1 log n. Here if I add, I'll get 2 times n minus 1 log n. Here I'll have 1 n. So 2 times n minus 1 log n plus n. So let me erase the stuffs. Okay. I think yeah, the space would be enough. Yeah. So this will go for n times, right? So I'll get 2 times n minus 1 log n plus n. That is the total frequency count, right? This is n times, and this is these and all 2 times n minus 1 log n. I am having 2 statements. That's why. Okay. And if I ignore the constants, I'll ignore 2. I'll ignore minus 1. So I'm getting n log n. So I'll have n log n. Okay. And n log n is somewhat worse than n, right? So you have to consider only this, not this. N should also be ignored. Okay, because n log n is something worse. It is linear logarithmic. You just see the order, right? Whereas n is just linear. Okay, it's just linear, but this is linear logarithmic. So you have to consider this only, right? Next question. Okay, so yeah, this loop will go for simple. I starts from 1 and it goes up to n I plus plus. So this loop will go for n times. Everything inside the loop will go for n minus 1 times. Super. This will go for log n times, because you can see the increment here, j multiplied equal to 2, which means that j equals to j into 2. So this will definitely go for log n times. Everything inside the loop will also go for log n times. That's it. If I add these up, I'll get 2 times n minus 1 log n plus n. If I cancel n minus 1, 2 here, I'll get O of n log n, which is very similar to the previous question, right? So yeah, this goes like that. Very similar to the previous question. I hope it is not the same question. No, it's not. Okay, super. So here you can see I starts from 1 to n divided by 3. So this will execute only n by 3 times. Okay, you can merely say n by 3 times, guys. There is no need to apply the formula, that is upper index minus lower index plus 1. Only in the case of finding the total frequency count, exactly the number you want. But here we are just finding the big O, so you can merely say n by 3 times, and everything inside the for loop will also execute for n by 3 minus 1, or you can approximately say everything inside the for loop will also go for n by 3 times. I'll just erase the word times. Okay. N by 3 times, right? And if you consider this loop, now you have to consider the inner loop, right? If you consider this loop, it starts from 1, it goes up to n, but it gets incremented in the form of 4. Okay, so you are dividing the problem by 4, okay, because it's j gets incremented in terms of 4, so you're dividing the problem by 4. So this will be n by 4, right? This will be n by 4 times executed. So everything inside the loop will also be executed for n by 4 times, right? Everything inside the loop will also be executed for n by 4 times. Okay, so if I add this up, I'll get what? I'll get 2 times, so it's very simple, guys. I'll get n by 3 and 2 times n by 3 into n by 4. So if I ignore the constants, I'll ignore 3, 2, 4, 2, 3, 4, and again ignore 3, and I'll get n and n square. N square is worse than n, so I have to write big O of n square, right? I have to write big O of n square, right? So that's the big O of this question. Just a minute, sorry. Yeah, so big O of n square for this question, right? Super. So I think I have one more question. I have two more questions, three more, sorry. Okay. Yeah, this is a while loop, guys, but it goes same like a for loop, right? But the only difference here is here you don't have the increment or decrement step. Okay, you have inside in case of while loop, right? Okay, super. So because of that reason, you can't predict how many times the loop will execute here, right? Okay, so you have to write it separately. So the outer loop, it starts from 1, it goes up to n. That's very simple, that's very clear. It starts from 1, it goes up to n. That's very clear. But you have to look at the increment also. Okay, so you can see the increment here. Okay, I equals to 2 into I, right? Of course, there is an inner loop here, but for outer loop, I is the counter variable, right? So you have to look at the increment here. Declaration is here, condition is here, and decrement statement is here. Here it is 2 into I. So I loop, that is outer loop, will execute for log n times, right? Because it is 2 into I. Okay, so problem will be cut down by a fraction 2 into I. So outer loop will execute for log n times. Okay, super. So inner loop, now you check at the inner loop. Inner loop, it is again j greater than 0, that's perfectly fine. It is j divided by 2. Again, inner loop, it is log n into log n. Why you are writing log n into log n? Because the outer loop goes for log n, guys. So immediately I have to write everything inside the outer loop will also go for log n time, right? So for that I am writing log n. Okay, after that inner loop will again go for log n times. Is that clear? Inner loop will again go for log n times. You can see the decrement of the inner loop also. It is j divided by 2. So it will again go for log n times. So if you sum up these now, I'll get log square n, right? Log square n plus log n. So I'll get log square n only. That is the big O. Okay, big O of log square n. That is the time complexity for this particular algorithm, right? Understand? Outer loop goes for log n, so everything inside also will go for log n. If outer loop goes for log n, and this inner loop again go for log n, so log square n. Outer it is log n, so log n plus log square n. Log n plus log square n, right? So you'll get only log square n. Super. Here again there is one more problem, two more problems actually, sorry. So here this loop will go for n plus 1 times. You can see n minus 0 plus 1, right? So maybe n plus 2, doesn't matter, we can take n plus 1. So everything inside the loop will also go for n times, right? So just write n, don't care about the conditions and all, just write n, right? This is with respect to the outer loop, right? You know that we have solved so many problems. Check out the inner loop, guys. It is j less than I square. Okay, j less than I into I, right? So the condition here is j less than I into I, j less than I square. Okay, so which means that my inner loop will iterate for I square times. This will end only if it reaches I square, right? This will end only if it reaches I square. My inner loop will iterate for I square times. My inner loop will iterate for I square times, which means that, okay, so how do I find the time complexity of the inner loop? It will iterate for I square time, guys. So but I is iterating for n plus 1 times, or else you can say n times. Okay, I is iterating for n times. You can see in the upper loop n plus 1 times, or approximately you can say n times, doesn't matter, right? So inner loop iterates for I square times. If outer loop I iterates for n times, then you can write inner loop iterates for n square times. Okay, because I iterates n times. Okay, j iterates I square times. Since I iterates n times, I can write j also iterates n square times, because j follows I square. I will iterate for n times, so I square will iterate n square times. So this will iterate for n square times. Everything inside the loop will also iterate for n square times, right? And we have one more loop, right? Assume this condition is true. Okay, then only you can go inside the loop, right? So you have to assume that condition is true. If you assume that condition to be false, then this will not be executed. Okay, and you are losing one for loop, and time complexity will not be correct. You have to assume the worst case, right? So you have to assume that condition to be true always, right? Okay, so okay, super. So you check the inner loop now. It will go for n times. I think it yeah, n times. Everything inside the loop will also go for n times, right? I hope it is correct. Okay, and if I finally add this up, I'll get O n power 4, right? If I'm not wrong, n into n square. So yes, I'm getting O n power 4. Yeah, so that is the total iteration. I mean, we go of this particular question. Okay, if I'm not wrong. I hope I'm not wrong. Yeah, there is a mistake here, guys. The mistake here is, here I'm underlying the condition, right? So it is j, it is not n again. It is, so it should not execute for n times. It is following j. So since j is executing for k less than j, means it is following j. Okay, but j is executing for n square times. You have just now seen j is executing for n square times. You can see that here. You can see that here. J is executing for n square times. You can see that here, right? So since k also follows j, it will also execute for n square times, right? So totally I'll get big of n power 5, which is very worse. Okay, which is very worse. Okay, So that's the idea here guys. This is something different, so please make a note of this. I follows n, j follows I square. Okay, j follows I square. Since I follows n, j follows n square, because I square, right? So I square becomes n square since I follows n. K follows j, j is following n square, so k also follows n square, right? Totally time complexity is n square into n, so n power 5, big O of n power 5, right? Okay, super. So yeah, this is the last problem guys. This will execute for n plus 1 times. You can see that here, n minus 0 plus 1, right? I think by this time you have to be very familiar with this. So everything will be executed for n times. Hold on. You have to just make a look of this condition. Here there is a condition here. So this condition will be definitely checked for n times. But if it is true, it is going for a single statement. If it is false, my else block will be executed where I have a for loop, where I have a loop. So if I consider the worst case, the loop will take more time, right? So of course I have to assume that this condition is false. If this condition is false for every iteration, then this will not be executed. So let me erase this off. Only else block will be executed, but that is okay because this is a single statement. This won't contribute much to the time. Okay, but here there is a loop. Okay, super. So this will execute for n plus 1 times again. Sorry, n times. Okay, I'm just considering the outer loop. So I've written n plus 1. So everything inside is n, right? Everything inside is n times. Okay, again okay, everything inside is n. So here this loop will execute for n plus 1 times, so everything inside the loop will execute for n times. We have only one statement inside the loop, so that will execute for n times. If I sum up this, I'll get n square plus n into n plus 1 plus n plus n plus 1. The worst case is n square, that is the highest degree here. So worst case is n square. So that's the big O of n square. This and all will not be considered, right? Because this is the highest degree. Of course, if you consider this is again n square, right? Yes. So these are the problems, guy. I hope it is very useful for you. I tried to cover almost all the basic time complexities. So yeah, there are something called as recursion also, but in this course we follow data structures in C programming. For that, I think this would be perfect. Okay, so everything else than this will be out of the scope of this course. Thanks a lot, guys.